All right, with that, now it's time for our next session, which was going to be conducted by Mr. Hupong, who has been engaged in the R&D and planning of intelligent network unified communication solutions since 2005. He has rich experience in designing and maintaining complex and highly reliable solutions. In 2015, he took charge of the design and R&D of some cloud platform services. In 2017, he started to engage in the R&D of AIOps related services. In 2018, as part of Huawei Ireland Research Center, he researched AIOps related capabilities and built data-driven intelligent O&M capabilities. Currently, he is in charge of the AIOps product planning and R&D. Here to talk on AIOps practice for PB level data and hundreds of millions users is Mr. Hupong from Huawei. Over to you, sir.
Amish for the introduction. Yeah.
Could you please turn on your videos? Oh, yes, sir. Thank you very much.
Yeah. Okay. You can see me, right?
I was able to see you. Yes, I can see you. There is a little bit of a lag.
Okay. Okay. So I will start the sharing.
Yes, sir. We can see your screen, sir. Yes.
Okay. Okay. Thank you. Thank you. Okay. Thank you for the introduction, and it's my great pleasure to be invited to present here. Currently, I'm in China. I returned from Ireland from this from this early year. So long time no present in English. If it's not fluent, please excuse me. Okay. So I will start start my topic today. Okay.
I think we have some skin free.
Looks like Mr. Hupong is having some. Sir, if you have a network trouble, you can turn off your video. You can stop sharing your video. Maybe that will help. Seems like Mr. Hupong is having some connectivity issues. We'll just give it a couple of minutes to see if he can resolve it. Your voice is breaking up in between. Your network seems to be a little unstable.
Ladies and gentlemen, while Mr. Hupong joins us back, just a gentle reminder to all the members of the audience to kindly post their questions in the Q&A box out in the chat section. Thank you so much, requesting all of you to divert all your questions in the Q&A box. We will hear from Mr. Hupong in just a moment from now.
Oh, looks like his network is completely down. We'll probably just wait for a few moments. Until then, I believe if there are any questions for previous sessions as well, please feel free to use the Q&A box. We will be making a note of all the questions, and we'll try to see if we can get them answered at a later time as well. Looks like Mr. Hupong is back. Sir, we cannot hear you still. We can see your screen, but we are unable to listen to you. Maybe if your slides are available with someone here, maybe you can directly speak. Santosh, is that possible?
Yeah, I can share that.
Yeah. Santosh, maybe you can inform him about that. Like maybe he can stop sharing and you can just share the screen and he can present it.
Roger that, I'm doing it.
Mr. Upong, maybe you can stop sharing. Santosh can share the presentation for you. You can connect only your audio.
And while that happens, I would like to point out to some interesting messages that we've received here in the chat section. We had Mr. Akram who said that he would want to see the recordings of this. He's enjoyed the sessions thoroughly because they were extremely innovative, informative, and educative. So if you all are enjoying and learning so much and educating yourselves from this summit and conference, do let us know. We'll be more than happy to hear you back. Let me remind all of you that we will have Mr. Hupong joining us in just a moment from now. I would also like to take the opportunity to thank all the members of the audience for their active participation. We've been receiving many, many questions from all of you.
Looks like Mr. Hupong is back. So maybe you can turn off.
Can you hear me now?
We can hear you now. Maybe you can turn off your video.
Okay, sorry. Okay. Yeah. So sorry for this. I'm not sure why this network is not good in the office.
It's all right.
Yeah.
Perfectly,
yeah, so please
perfectly
disconnect. Yeah, let me share my screen. Yeah, please.
Sure. Over to you, Mr. Hupong.
Yeah, no, I'm using. Sorry for this. So now you can see my screenshot, right?
Yes.
And the voice is good.
Loud and clear.
Okay. Sorry for the. I'm not sure why this network is not good. Now I'm using this Wi-Fi sharing of my phone.
Sure, sir.
Yeah.
Over to you.
So, okay. So then I will start. Okay. So just today my topic will containing all these things like the service introduction and our practice part. Actually, we have the data governance and monitoring and the data intelligence part. Data intelligence part is our most important part. We have some more slides here to introduce this part, and also we have the summarize and looking for the future. The introduction of our CPG cloud service. The CPG cloud service is under the CPG consumer business group. The vision of the CPG is through the 1+A+N to build the intelligent new life experience for the users. And our CPG cloud service vision is to provide a high quality smart life experience for hundreds of millions of users worldwide. And until now, the monthly active user for CPG cloud service has exceeded 700 million, and the active of the registered developers has exceeded 2.7 million. Here are so many provided services here for our end users. And just like the introduction said that from the 2017 we started our practice in AIOps. From building this data platform, to support the real-time OCS data cleaning and the data visualization. And after 1 year, from 2018, we started to build this AI capabilities. And also we built a dedicated AIOps research team in Ireland Research Center to focus on this AI capabilities to build these models for different scenarios. Here we have a lot of challenges, like the the data is still growing very fast. It's nearly double per year. So because our service is increased very fast and the data is increased very fast too. And also you know that we with the increase of the data, we spend a lot of money in the AIOps platform itself. We spend so now is a lot of challenge for us to balance the data value and the data cost. So also we received a lot of diversification of requirement for the data analysis and also data decisions based on the data. So a lot of requirements from different services. So for all these challenges, we have some countermeasures, like we built a open and self-service data platform, which we can, all this SRE can use this data to do this data analysis and sense. And also we build our ChatOps. Later I will give some introduction of our ChatOps to facilitate the efficiency of the data access. And also we measure we measure the data and reduce some access of the no value logs. And also I have done some pre-aggregation from the access side. And also the algorithms, we continually optimize these algorithms to reduce the requirement on this raw data. So we can reduce this requirement of the log size. And for this different requirement, data analysis requirement, recently we started to build some platform to support this kind of data analysis orchestration to support the flexible data analysis by the SRE. So for all this, I'll give some short more introduction in the following. Firstly, so I will start to explain our AIOps practice. Firstly, I will introduce our definition of the digital SRE. So what is a digital SRE? Digital SRE, recently with the development of our AIOps, we realized that we need like a digital SRE to access the SRE. So what the digital SRE have, right? So you can see here. So firstly, the data. Data is the fundamental of the digital SRE. Is also is the fundamental of the AIOps, right? So the data, including the metadata for like the CMDB data. CMDB is the configuration management database. Is containing all this infrastructure metadatas. And also we have this KPI metadata, and also the data relations and the topology data. All this is metadata. And also we have the monitoring data, like different log data, the indicator and the service quality data and the user experience data. So all this data is the fundamental, is very important for all this. So we have the data platform to support this all this data governance and the related sense. So and the brain is the core part of the digital SRE. So the brain consists of numbers of AI services. So like the sense of the data, like the anomaly detection, the data analysis, and finally the automated the decisions. So this is the brain, is the core part, is very important, is our many work here to build the AI based to automate this analysis and these decisions. And also we have a separate team to build this automation, which is act as the hand of the digital SRE. This is like for example, like the infrastructure as code is helping the service deployment. The EAP is our event action platform, is an orchestration of the workflow to support the workflow orchestration to automate this execution of the like for example, like some different scenarios, support different scenarios. And also like the RPA, we are doing some robotic process automations also. For the finally, recently we are trying to build the bot. So digital SRE act as a bot, need to have this NL interface for the SRE. So the SRE can through this NL interface to interact with the digital SRE, right? So this bot we build is powered by this knowledge graph. It's not we will give some more introduction here. So we are thinking that the digital SRE is trying to assess the SRE to automate most of the work. So I will start to introduce this data governance part. So data governance part is mostly the capability of the data platform. So fundamentally, it's from the data access, data cleaning, data repository, and the data visualization. All these things is the main capability of the data platform. So recently, with the development of the data platform, we realized that we need this kind of indicator warehouse. So from last year, we built this capability to support to unify this metric calculation rules and also to decouple the logical model and the physical model. So this can improve the efficiency. For example, like before, with all these scenarios, you need to, based on this physical database, you need to define this calculation rules separately. So you need to build this different times, right? So for the same indicator. But now with the logic entity definition and with the definition of the indicator, all these scenarios can share the definition of the indicator, and they can definitely improve a lot of efficiency here for the definition of the and maintain. It's easy to maintain all these indicators. And also with the indicator support of the indicator, we can organize the indicator more better. And this we can organize the data in the service domain from the service domain perspective, and also from the full stack perspective to organize all this data and all these indicators. So this organized data will bring a lot of benefit to easy to measure, easy to find the data, and easy to use the data. And for the monitoring, we have already built this self-service dash configuration capability, which can support the SRE to configure the dashboard back himself. So you can see if you go to China, go to Nanjing, we have a very big monitoring center. You can see a lot of monitoring dashboard is here. It's maintained, it's built and maintained by the SRE itself. This is an example of the monitoring from the APP gallery case. So you can see for the he can monitor the APP download count. He can monitor the top APP the download trend, and also he can monitor the failure. So for the SRE, he can use this platform to do a lot of customized monitoring by the SRE. This is another example of the monitoring from the network domain. So for this, like the BGP, you know, we have different provider of BGP for the data center, but this monitoring is monitoring to find that this BGP provider have some latency compared to the other BGP provider. So from this dash, you can find that this is related to the DNS reservation. But you can see that all this is based on this domain knowledge. He can use this domain knowledge to build this dashboard to help to analyze this kind of problems. Also, this is for another case for the CDN monitoring. CDN monitoring, like for the CDN latency for different CDN providers, and we found that one CDN provider the latency is higher than the others. And we through this drill down the monitoring data, we found that some of the IP of this CDN is have this cross domain access problems, which is the core problem. The fellow problem is about the IP repository problem is not accurate enough. So this is some kind of domain knowledge based used this data platform to do this kind of data monitoring. So I want to, so this kind of case is we have a lot of this kind of case. So through this case, I want to summarize some point here. So we are thinking that the SRE have the domain knowledge. So this is the very important precondition. So and the open and self-service capability is able to inspire the innovation of the SRE. So the open capability is a very important capability that we have already built in our data platform. All these things can be self-serviced by the SRE. And we also think that the data operation is a very important work for the SRE in the future, like the data operation for the ops. Data operation for the ops is a very important work. Using the data to monitoring and to help the decision making for the SRE, and for our AIOps platform itself, to learn the domain knowledge from the SRE is a very important challenge for us. How to store this knowledge, how to use this knowledge, and how to use this knowledge to automate the analysis and the decision making is a very important thing for our AIOps platform. So next is about the data intelligence part. I will give some through this end-to-end flow to give the introduction of some of our work. This is the quality assurance is four scenario. Quality capability from the gray upgrade. When you do the upgrade, we need to do some evaluation to say that this grade upgrade is okay or not. So we have this kind of AI-based service to support this automatic evaluation of the upgradation is good or not. And also we have this anomaly detection to support to detect this health of these services. And also with the input of the detected alarms, we can have some aggregated capability to aggregate all this alarm into the event. And with this event, we can have this root cause analysis capability to find this real root cause. And this root cause result will push to the SRE through this dash or through this chatbots. And also finally, the auto hearing for some of these CDM problems, we are build some intelligent scheduling capability to automate this auto hearing capabilities. So I will introduce quickly, go through this part for each of the capability. So anomaly detection is all time sequence based AI services. So for each of the time series data, which is the KPI, for this KPI, it can be your delay, can be your successful rate, kind of service KPIs. We can build this pre-trained model to detect this dynamic threshold for this KPI to monitoring these problems. For example, this sudden increase of the delay can be identified by this threshold here, and this threshold is learned by this pre-trained models. And also we have this correlated request KPI with this delay KPI. So you can see during this increase of the delay, the request is suddenly increased also. So for this actually can give a lot of message for the SRE to analyze these problems. For the anomaly detection, actually we have already supported millions of KPIs from 2018 until now. So to support more KPIs, we have a lot of challenges to see that we have a lot of different types of the different features of the data. So you can see here at least some of the data. So for each of the data, actually we build several different type of the algorithms to adapt this kind of different features. So this year, from this year, early this year, we start to build this adaptive anomaly detection capabilities, which is through this with the input of the feature of periodicity, volatility, and sparsity of the feature of the time series data. We automatically classify this this data and to decide which is the best model for this detection of this time series data. So this actually helped a lot for maintaining this monitoring for different type of different type of features of the time series data. And after the detection, we have some alarm suppression capability. What is this capability looks like? You know that when we detect this kind of problems, not all the problems is needed to be handled by the SRE. For example, like this is our KPI, which is the request count is very low, and from the threshold itself, this is an anomaly definitely. But for the SRE, through this multi-dimensional drill down analysis, we found that this is actually this problem is caused by some single users. So these problems from the SRE perspective, this is not no need to handle this type of the problems. So we before we sending this alarm to the monitoring system, we did this alarm suppression capability, which is used this multi-dimensional drill down capabilities to suppress these alarms. And the next is the alarm aggregation. Alarm aggregation, actually, we divided into three levels of the aggregation part. Firstly is the best the relations. Actually, this relation is all about the metadata relations, like the host and the interface. All this relations is maintained in the all this metadata is maintained in our CMDB. So we use all this metadata to do this correlation of the alarms and aggregate these alarms together. But for example, if this alarms is happened in the same host, so all this type of, no matter it is a CPU alarm, or is a disk alarm, or is a port alarm, or is a KPI alarm, so all this will be aggregated together. But this the second level of the aggregation is from end to end. So later I will introduce our diagonal analysis from end to end. So we need to find the relations from the, for example, from crossing the models. So this second level aggregation is use this result of the, for example, the co-chain diagonals result used as the input of the aggregation. So this can, for example, if all app monitoring some user experience KPI is bad. So whether this problem is caused by some interface, by some service side module. So this we need to correlate this KPI to the interface, and then we, through this interface, we can find that this interface is caused by this service model. So this is the second layer of use this root cause analysis output as the input of the aggregation. The third level of the aggregation is to use some event, because most, you know that most of the SRE the problems is from the change, right? From the change, from the operation event, and also from some configuration change. So when we find some root cause, we also can, through this metadata correlations, we can aggregate this root cause to this event, whether this problem is caused by a change, whether this problem is caused by operation. So this is the third aggregations. This is our root cause analysis algorithms is multi-dimensional drill down analysis. I will not give much details or explanation about this algorithms. This algorithm actually is started with this from this paper, but like the calculation of the EP, the calculation of the surprise is mostly from the paper. But we did a lot of optimization for the add some more element, and also we use some domain knowledge. We use some domain knowledge to do this post processing. So some different dimension is have different relations. So different dimension is have different meaning. So this meaning the algorithms cannot understand, but the domain knowledge can understand this part. So we embedded some domain knowledge to do this post processing for this algorithms output. This is our the four-link root cause analysis engine. You can see that we have already built this this autumn root cause analysis capability, like the core-chain root cause analysis, multi-dimensional drill down analysis, the log analysis, and the traffic source tracing analysis to find the source, the traffic which is the source of the increase of the traffic. And we built this engine to aggregate, to combine all these capabilities to do the decision, to do the analysis, and to do the decisions. So actually, this is our domain knowledge based, or is some rule and plus AI based engine to combine all this capability together to make the decisions. I think that this is our design for this part. This is an example. I will not expand the details. You can see this problem is alarm is from two sides. One side is from the network side, is from the SLB, and also the alarm is from the service side. All this alarm is aggregated into one event. And for this one event, actually, we triggered this the core chain analysis to get this path of the problems. We found this root cause of the service. And also, after we found this service, we triggered this multi-dimensional drill down analysis capability to find which is the interface, which is the encode of the interface have the problem, and we automatically found this sub-dimensions to show to the SRE to find this all this information to show to the SRE to help the SRE to analyze these problems.
Mr.
So this
Hupong,
is our.
Sorry to interrupt.
Yeah.
We will have to wrap it up in the interest of time. We have 1 minute to go. We will be taking one question after the wrap up.
Okay, I will be fast. Yeah, several many. So for the ChatOps is actually we build a knowledge graph based ChatOps. For this knowledge graph, we have a cooperation with the UPM. Actually, this is a published paper in ISWC. So we based on this knowledge graph, we build our ChatOps. Actually, the ChatOps is to solve this problem. The goal of the ChatOps is easy to retrieve data, easy to retrieve AIOps service, and rich visualization way to show the data, and support the analysis and decision orchestration, and also easy to execute the automation actions. So the ChatOps will be an important entry for the SRE to orchestrate all these capabilities. And this is some of our capability to show through this ML-based command to support it. Actually, for this case, we support this workflow influence and auto generation. This is also the result from our cooperation with the UPM. Through this knowledge graph, we can do the influence and automated generate this workflow. And this is some like to support the execution of the share command through this the chatbot entry, and also for this like the alarm analyzer to get the alarm, to analyze the alarm, and to act on the alarm, and this is supported currently. This is a very important capability we supported in our ChatOps to support this data analysis and decision orchestration, to support, which is supporting the fundamental capability to support retrieve the data, easily to retrieve data. All this data is stored in the AIOps or is in CMDB, and to support analyze the data, decisions and visualizations, and to execute the actions. So the capability of the analysis is Python based. So and all this actions is ChatOps command based. So we combine this command ChatOps command and the Python based data analysis way together to support this kind of data analysis and decision orchestration, which we will suppose this capability can be a very important capability to support the flexible data analysis and decision making. Finally, I have 2 slides to summarize. So for the data part, our goal is to automate the governance and easy to access. And you can see we have already built this indicator category, and we have fully opened our data governance service. And next, what we are going to do is to for the normalize the data, we will build the capability to automate all this configuration. So, for example, if standardized SLB data, this data will be automatically access, clean, and build and create the visualization. All this is automated. And also, we are trying to build our NL to Soccer capability, which is we have already built a cooperation project with Cambridge Professor Andrews to support this kind of capability to help to improve this capability to easy to access this data. Finally, is the data intelligent. Data intelligent, the goal is to automate the analysis and the decisions. So recently, we see a paper from the academic of Chinese Academy of Science, Zhangbo. This is a paper. The name of the paper is towards the third generation of AI. He defined the AI 3.0 is AI 1.0 plus AI 2.0. AI 1.0 is the knowledge, mostly knowledge based, and AI 2.0 is mostly data driven. It's like machine learning and deep learning. So AI plus 3 capability is to combine all this capability. So for our AIOps, we are thinking that because our AIOps, we need this AIOps 3.0. Like for some of the scenarios, we can use the statistic model to support. For example, like the alarm detection, because for this scenario with enough data, well-defined and predictable and single domain scenarios, we can use this statistic model to support to automate this part. But more, we need the knowledge, because as we expanded before, a lot of scenarios we need the domain knowledge to analyze the data, to know how to analyze the data and how to make the decisions, like the scenarios for the service quality judgment, sequential analysis, and faulty isolation decisions. All the scenarios need domain knowledge. So how to build this domain knowledge based decision making capabilities is our challenges and is our goals in the future. Actually, we have done some of the work, like the knowledge based workflow automation and data analysis orchestration, which is expanded previously. So this is still a lot of work to do, and also we are expecting to do a lot of cooperations with professors and university all around the world to help this part also. Our aiming is to build this intelligent AIOps machine intelligent decision center with this knowledge category catalog to support the digital SRE brain. That's all from my side. Thank you.
Thank you so much, Mr. Hupong, for that extremely informative presentation. Well, we definitely do not have any questions from the external members out here, but we definitely have a lot of questions from your colleagues from Huawei. So they will be posting it offline. You can post it offline in the Q&A section. We will have Mr. Hupong addressing all of them offline. So do send in, rather pour in all the questions that we have for Mr. Hupong. Once again, thank you so much to you, sir, for doing this and giving us your time.